Okay, it's time to start setting up the working environment. Since we have VirtualBox already installed and configured, the next step would be to download, install, and configure GNS3 and the network we will use to test our applications. To download GNS3 and install it on your Windows host operating system, go to My Google Drive. That is the link from the previous section. On the Google Drive link, go to the third folder called GNS3 and download the installer for the version I'm using for this course and the additional files in the folder. Now, I know that in the beginning of the course, I said that we are going to use GNS3 version 0.8.3, but I will use the next version, which is 0.8.4, and that is the version you are going to find on my drive. Why am I doing that? I'm doing it as a workaround for any of you who have Windows 8 or 8.1, because there are a lot of cases in which connecting the virtual machine to the GNS3 network using an Ethernet switch doesn't work. And that's why instead of a switch, we are going to use a hub in this newer version of GNS3. Okay, it's time you finish the GNS3 installation. I have it already installed right here. As soon as you install GNS3 on your host operating system, remember, not on your virtual machine, on your host operating system. In my case, I have Windows 8.1. As soon as you install it, get your own copy of a Cisco router iOS, preferably a 2691 image with routing capabilities, as I will use this router model to test our applications. But I think you should do just fine with other router images too. Now let's open GNS3 and create a new project. We should first give it a name. Let's say Python Udemy, and a location to save its files. Okay, and we're good to go. Since I already have an iOS image loaded using the menu in Edit, iOS Images and Hypervisors, I should be able to simply start drag and dropping routers through the emulated network. As I said, I will use the 2691 router model. Now it's time to go to the picture in the folder you downloaded from my drive and see how our network should look like, so we can all be on the same wavelength when testing our applications. Okay, so in this picture, we have a device called Debian VM. That will be our actual virtual machine. We will see how to link our Debian virtual machine to this network in the next lecture. We also have another device for which you don't need an image. It is just a hub. I gave it a fancy name, management switch. It simply helps us to connect the virtual machine to each router using a separate management network, the 192.168.2.x/24 subnet. This subnet will be used for accessing the devices via Telnet or SSH. In the right side of the picture, we have 5 routers with the same image and model called R1 to R5 with single area OSPF running on each of them for routing purposes. There are also some loopback interfaces there, and that's about it. Now let's get into GNS3 and start building. So let's start with the routers and drag 5 routers to the working area. Okay, I've done this. Now let's make the connections between them using different types of cables. You can see that R3 is connected to R4 via UTP cable, and the rest of the connections are made through serial cables. We should go and double click on each router first to add some slots, some WAN interface cards called WIC2T to each of them. So let me go ahead and do this. Go into R1 and slots, and down here select WIC2T and then OK. I will do this for each router that needs a serial connection. Okay, I'm done. Remember that R3 will have 2 WAN interface cards, so 2 WIC2T modules, because it will connect to 3 routers via serial connection. Now let's also add the hub and connect it to each router on each router's fast Ethernet 0/0 interface, just for consistency. Okay, so Ethernet hub. Okay, I've made all my connections. Remember to always check with the pictures so we can have the same interfaces between the routers connected, and also the same network design in place. Okay. Now it's time to take care of the configuration part. For this, go to the GNS3 folder that you downloaded from my drive. There you can find the configuration files for the routers, R1 to R5, with IP addresses and OSPF already set up, so you don't waste any time with this. Now let me start my routers here and manage their configurations. So press this button right here and just wait for a while. Okay, they are up and running. Now using double click, we'll open the console on each router. So let me go ahead and do this. Okay, now it's time to open each file in this folder with the text editor and paste its contents to the console of the corresponding router. First, please remember to enter the global configuration mode on each router before pasting. So, for example, this is the configuration for R1. Just copy, Ctrl A, Ctrl C, and then go into the console of router 1, do a conf T, and just right click to paste the configuration. Okay, and it's done. Now let me do this for each router. Okay, I'm done with all the routers. Now let's issue some commands to check the configuration. So let's start with R1. Let's do a show run first. Okay, looks like the configuration is in place. Okay, let's do a show IP interface brief. Okay, the interfaces are up and running. Let's also do a show IP OSPF neighbor. Okay, so we have OSPF connectivity. Everything seems okay. Great job. The last thing we should do on each router in order to have our settings saved is the copy run start command. So let's go ahead and do this on each of them. So copy run start, the double enter. Let me copy this, sorry, and do it on each of the routers. Okay, now it's time to save our settings and the entire project. So let's go into GNS3. First, let's do an export. This will export our configuration files to our Python project directory into the configs directory right here. Okay. And now let's do a save project. And that's it. Optionally, for better visibility on our network design, you can add text labels in GNS3 like you see in the picture here to label interfaces, subnets, and IP addresses. In the next lecture, we are going to connect our virtual machine to this network, thus finalizing our work environment.